Today's video is going to walk through the concept of function notation, which is something you guys have seen in the past. It's really just the idea that y equals is the same thing, or an equivalent form of y equals is f of x, where you have the f parentheses x. They really represent the same thing, but f of x you can do a whole lot more with. You can label an equation not only as y equals, but f of x, g of x, h of x, k of x, z of x. You can just define more types of functions and kind of make them stand apart a little bit more. But there's even more you can do with it in terms of like shorthand math notation, the symbolism behind it of what it could kind of represent or tell you to do without writing out all these words. So this video is just about getting comfortable with what does this notation allow us to do? What does this notation mean? What does it say? And how can we use it? So what we've seen in the past is, generally speaking, an equation is always like y equals 2x plus 3. And then what they could ask you to do is say, solve for y when x is negative 1. So if you saw that direction and the question was asking you to solve for y when x is negative 1, well, hopefully you would recognize that I should just take this x value of negative 1 and I should plug it in right there, and whatever I get back is the y value. That's the whole concept that we deal with functions a lot of times. It's all about input, output. Like what you plug into the equation is, generally speaking, the x, and you get back the y. Well, here is an equivalent form of the directions. And notice how there's not as many words written. And you don't have like a full-on statement direction of what to do. What you have instead is just this. But this statement right here, this math notation right here, tells you to do the exact same thing. So they could say this: f of x is 2x plus 3. Okay, so here's a function of x. Notice how the variable is an x here. It's a function of x. And this function is 2x plus 3. Well, what they're asking you to do is find f of negative 1. Notice how it's usually f of x, but now it says f of negative 1. So it's asking you to do the same exact thing. Plug in this x value right here, and whatever you get back is the y value. So if I were to find f of negative 1, I would plug in negative 1 in for this x. And I would say f of negative 1 is negative 2 plus 3. F of negative 1 is 1. So how do we interpret this statement? Well, I plugged in negative 1, and that was my x coordinate. What did I get back? My y coordinate. So it's being able to interpret this statement for x's and y's, and now let's just be able to plug them into these examples. So for part A, we're given 4 different functions, g, f, h, and j of x, and we need to evaluate. So this is where we plug in, substitute in. So g of 10, I plug that in right here. I get negative 3 times 10, or negative 3 times 10 plus 1. So I get negative 30 plus 1, negative 29. F of 3, plug it into the f of x function. 3 squared plus 7 is 9. Squared plus 7, 16. H of negative 2, plug it in right here. 12 over negative 2 is negative 6. But this notation can be done with not only numbers. We could plug in anything, variables, symbols. For this last one here with the numbers, plug in a 7 into this j of x. 2 times 7 plus 9. 14 plus 9, 23. But here's h of a. You don't do anything different. You still need to substitute in the value that you see, but this time the value I see isn't a number, it's a variable. But I'm still going to plug it into the function. H of a is going to be, and here's where I plug it in. Let's follow this line right there. It's not h of x, it's h of a. So I'm plugging in a in for the x. My answer? 12 over a, and that's it. You can't simplify it down to a number, and that's okay. It's just asking us to plug in that value. For the next one, it says g of b plus c. So you're literally going to plug in the quantity b plus c into our g of x function. So g of b plus c is going to be equivalent to, well, here's what we have. Negative 3, not times x, but b plus c, plus 1. And you could do some distribution if you needed to, but that's all it's asking you to do, plug in. And let me just show you one more example for a second. Let's say it was saying find f of smiley face, okay? Just to show like you could literally plug in whatever you want. F of smiley face, here's the function right here, would be smiley face squared plus 7. Okay, I hope you guys see that like anything could be substituted in based on this notation. So now it's just asking us to see it in a different way in terms of x's and y pairs. So it says on our graph, given this function, find f of -4. Well, remember this value right here is representing the x value. So when it's saying find f of -4, it's saying find the y value. So f of -4, when x is -4, the y value associated with it is 2. F of 0, when x is 0, the y value is 0. F of 3, when it's 1, 2, 3, the y value associated with it is, you're going to have to approximate -2.75. Oh, sorry, -1.75. -1.75, just an approximation. F of -5, when I go to -5, we're right here at an x value of -5. What do we get back? The y value, which is 0. So then do the same thing but in reverse. So here's the statement, here's our points. Now here's the statement, plot the points. So this is x value, this is y. What you get back is y. -1, 1. That's the coordinate. 2, 7. 1, -1, 3, 0. And it's saying plot these. So -1, 1. First one's plotted. 2, 7. 2 up to 7. Right there. I think that's 7. 1, 2, 3, 4, 5, 6, 7. Okay. 2, 7. 1, -1, and 3, 0. So we're taking our f of x statements, converting them to points, which we can then plot. And our last one, our last set, evaluate each function. So here's what it's saying. It's saying k of a is this function for a plus 2. Notice how it doesn't say k of x. The reason is because it's not a function of x. Look at the variable that's here. It's an a. So if it says k of a is this function of a, so that's the variables we're working with. And then it says find k of this right here. Remember, whatever is right here is what we plug in for the variable. Okay? So k of a minus 3 is 4 times, not a minus 3 plus 2. There we go. Okay, look at this one. Notice how it's h of t, not h of x. So h of t, our function here, is -2t plus 2, but it says find h of, not t, -3t. So whatever you see here is what gets substituted into your equation. H of -3t is equal to -2 times not t, but what they tell us to substitute in, -3t plus 2. And once again, you could multiply that and call that a 6t, right? Plus 2. And you could distribute this if you wanted to as well, based on what the directions are asking you to do. We're just really focusing on what does that substitution look like. Okay, so this is helpful through this unit because we're dealing with a lot of f of x, g of x notation, and this find f of some value like f of 7. What does that mean? So that's what this video was trying to get at, understanding the notation, ways that you can work with it, and how the directions don't even need to be given in words like this, solve for y when x is -1. Now they could just be given like this, find f of -1, and you got to know what that represents. Okay, that's it for today.